Okay, so question number 2. Astronomers have measured that the magnetic field of some stars are of the order of 10 raised to power 10 Tesla. The physicists have measured the magnetic fields of some laboratory magnets to be 1 Tesla. So there are two measurements that they are making. So one is for the astronomical body, which is completely huge, like 10 raised to power 10 Tesla, and another is just one magnet, which is in the laboratory. The magnetic field is, of course, very low, which is 1 Tesla. So you are making the measurement of this order, like you're using the same instrument, but there is 1 Tesla here and 10 raised to power 10 Tesla for the astronomical body. Three types of uncertainties are given: absolute uncertainty, fractional, and percentage. What type should the group use to compare the precision of their measurement? Now, couple of things that you have to understand here. Now, first of all, you must know what is the difference between these three types of uncertainties. So let me explain you that. Let's say you are measuring a length of a road or something, and it comes out to be 10 meters, and you are creating an error of 1 meter for every 10 meter. And then there is another length, you can call it length 2. So that length is very big, a kind of 100 meter, but still the error remains 1 meter. Now, absolute uncertainty is plus minus 1 in both of the cases. This factor is called the absolute uncertainty. So clearly the absolute uncertainty is the same for both of these measurements. Clear? But clearly we can say that this measurement is far better than this measurement. Why? Because this is the error of 1 meters for the length of 10 meters, and this is 1 meter for the length of 100 meters, which becomes a genuine case. So that's not a problem, I would say. So absolute uncertainty is not doing justice for these two things, isn't it? So we have to create another types of uncertainty, which is fractional uncertainty. Now the fractional uncertainty is when you take the fraction here. So this is 1 by 10, it becomes zero point 0.1 in one case, and in another case it is becoming 0.01. So clearly this is showing you the precision of your instrument, that even for 100 meters, what is the error that you are going to make. So this is the precision of your measurement. And what is the percentage uncertainty? When you multiply the fractional uncertainty, that is delta L by L, this is fractional uncertainty, you multiply it with 100, becomes the percentage uncertainty. So the percentage uncertainty here will be kind of like 10%, no, 1%. You're multiplying with 100, yeah, 10. And here you multiply, it comes out to be 1%. So you can see that the percentage error in this calculation, in the first measurement, is whoopingly 10%. That is too high. And the measurement in the L2 is coming out to be 1%, which is fairly good. It means that both of these can be used to find the precision of the measurement. Well, these topics are very important for paper 1B, and I tell you, for your IAs. If you are writing the IAs, you have to consider these things when you're making some measurements. You have to find the errors. So this is what is propagation of error. Like, you have to fill your IA with this kind of information. Then your IA becomes stronger. Clear? So it's very important for us to understand what is happening here. So the answer will be 2 and 3. So 1 is wrong. So C will be the correct answer for this question. And this is how we do this question. Okay, dear students, thanks for watching. This is Professor Varun. See you in the next video. Bye.